Here we are in Chapter 1 review exercises, numbers 45 through 50. Here we're finding these, which means we could be adding, subtracting, multiplying, scientific notation. So, a couple of quick reviews. On addition and subtraction, we have to get common exponents. We might have to use that left up trick to get those common exponents. And then we add or subtract the decimals. And that exponent that we found that was common stays the same. In multiplication, we don't have to get common exponents. We just multiply those decimals together and then add the exponents. And we may have to use that trick of left up to put it into proper scientific notation. Let's go. Number 45. We are adding them, so we need them to be common exponents. Oh, they are. This is great. 5.30. The zeros kind of doesn't need to be there, but 10 to the negative 9. Good. 0 plus 0 is 0. We don't need that guy. 9 plus 3 is 2. Carry a 1. 1 plus 6 is 7. Plus 5 is 12. 12.20 times 10 to the negative 9. Good. Notice that exponent remained the same. This is the right answer, but it is not in good scientific notation. So we have to put it into scientific notation, which means we're going to move this guy 1 to the left, up. So that means it's going to be 1.220 times 10 to the 10th power. Oh no, negative 9, not to the 10th. I just messed up there. Negative 9 plus 1 is a negative 8. Ah, there we go. That's looking good. Okay, next one. Number 46. 8.015 times 10 to the 6th plus 5.70 times 10 to the 5th. Oh, they're not common exponents. We're adding. We need to get common exponents. So we're going to go, this guy has to go up 1, and that guy will go to the left. That 0 kind of doesn't help us. So we're going to have a 0.57 times 10 to the 6th. That's what that just changed into. 0.570 times 10 to the 6th power. So let's add them up. 5 plus 0 is 5. 1 plus 7 is 8. 0 plus 5 is 5. And the decimal comes straight down. 8.585 times 10 to the, and the exponent stays exactly the same. Good. Number 47. This is multiplication, which means we don't have to get common denominators. We'll just put this guy 6.9 times 10 to the 10th right underneath. And let's multiply these decimals together. 9 times 5 is 45. That's a 4 up there carried. 9 times 1 is 9, plus 4 is 13. 9 times 0 is 0, plus 1 is a 1. Then 9 times 3 is 27. All right, now with the 6. Let's ignore those for a little bit so they don't mess us up. 6 times 5. Oh, we needed a 0 there first. Then 6 times 5 is 30. That carries a 3. 6 times 1 is 6, plus 3 is a 9. 6 times 0 is 0. That's a 0. 6 times 3 is 18. So adding them together, we get 5, 3, 10, carry the 1. That's an 8. 2 plus 8 is 10. Carry the 1 is a 2. 208. 035. Good. Now, where does the decimal go? Don't jump to the scientific notation. Thinks it goes at the 2. We have 1, 2, 3, 4 digits behind the decimal place. 1, 2, 3, 4. So it is 20.8035 times 10 to the, add those guys together, 18. Okay, that is the correct number right now. However, it is not an appropriate scientific notation. So let's note it that this guy must go to the left to put it in a scientific notation, which means that guy has to go up 1. So that is 2.08035 times 10 to the 19th power. Excellent. Okay, number 48. 9.54 times 10 to the negative 5th plus 5.9 times 10 to the negative 4. Let's put these both to the biggest one. So we're going to go up 1 there. That'll put it to a negative 4. So that has to go left. So we have 0.954. Let's write that out. 0.954 times 10 to the negative 4. Now they're the same exponent. And we line up the decimals. 0 plus 4 is 4. 0 plus 5 is 5. 9 plus 9 is 18. 18 gives us 6. There we go, 6.854 times 10 to the negative 4. And that looks like good scientific notation with only one digit to the left of the decimal. Number 49. 8.01 times 10 to the 7th times 3.1 times 10 to the 5th. We do not need common exponents. We'll just put this 3.1 times 10 to the 5th right down below it. Now we're going to times these guys right here. 1 times 1 is 1. 1 times 0 is 0. 1 times 8 is 8. Now put a 0 down there. 3 times 1 is 3. 3 times 0 is 0. 3 times 8 is 24. And that is 1. 0 plus 3 is 3. 8 plus 0 is 8. 2, 4, 8, 3, 1. Where does the decimal go? We have 1, 2, 3 digits behind the decimal. That's right there. Oh boy, times 10 to the, remember what happens with these exponents? They add. So that is a 12. Now, final, put it into scientific notation. So go ahead and do that. That's left, and that's up. So 2.4831 times 10 to the 13th power. Now let's make that a little bit nicer. There we go. And the last one. 9.54 times 10 to the negative 5th times 7 times 10 to the negative 3. So we're going to times these guys again. Let's just do the decimals. There we go. 7 times 4 is 28. 7 times 5 is 35. Plus 2 is a 37. And 7 times 9 is 63. Plus 3 is 66. 6, 6, 7, 8. Where's the decimal go? We have 1, 2 behind the decimal. 1, 2. There we go. Times 10 to the, they add. Now, when you have a negative 5 and a negative 3, they're both negative, so they both go in the same direction. That's a negative 8. Not in scientific notation, though. That's the right number, but we got to move it. Let's use a different color just to draw attention to it. This is going to go left, and that has to go up 1. And so that becomes 6.678 times 10 to the negative 7th power. Excellent.